Assalamu alaikum students. Let's start with the name of Allah. Bismillahirrahmanirrahim. Today's our topic of class 10th physics, chapter number 10, simple harmonic motion and waves. Today our topic is damped oscillation. The definition of the damped oscillation is written here. Oscillation of a system in the presence of some resistive force. What is meant by resisting force? Resisting force is the force of friction or air resistance. In the damped oscillation, we discuss the ideal system. When we discuss the ideal system in the absence of resistive force, force of friction or air resistance, then oscillation is continue indefinitely due to restoring force. But practically, we not apply an ideal system, so resistive force is applied on a vibrating body due to friction. Friction retard the motion of a body. So due to the force of friction, reduce the amplitude of the vibrating body. So force of friction retard decrease the mechanical energy with the passage of time. You can see in this animation, along x-axis time is taken, along y-axis displacement is taken. You can see the sign of positive and negative. Positive sign show the increase and negative sign show the decrease. You can see in this figure, amplitude of the damping system is decreasing with the passage of time. Now move toward the example. We can take the practical application of the damped oscillation, shock absorber in automobile. In this figure, you can see the shock absorber. Shock absorber consists of a single tube. Now you are seeing the interior part. It consists of two compartments. First compartment is separate. These two compartments are separated by piston. Working chamber is present and that is filled with oil. This compartment has the piston rod. Next compartment is high pressure gas chamber that is filled with pressurized gas. So in this way, shock absorber is working rebound effect to keep the working chamber constantly filled with oil. Scientists designed the shock absorber in this way that the piston is made up of metal, so this separates the gas from the oil by preventing mixing of it. When we compress the shock absorber, piston rods is enter into the shock working chamber and oil is compressed and it press gas and reduce the volume of the working chamber. In contrast, when the shock absorber is extended, the piston rod is leave the working chamber and reduce the gas pressure which cause to rebound to move piston again. In this way, shock absorber is working. When a car travels over a bump, the shock absorber absorbs the damp vibration and it's converted into their energy, especially into heat energy of the oil. Now move toward the next topic is the wave motion. What is wave? When we hold a string in our hand and force is applied in a string, then wave is produced. The definition of a wave is written here. A wave is a disturbance in the medium which causes the particles of the medium to undergo vibratory motion about their mean position in equal interval of time. For wave is basically required the medium. Medium may be air, water or a string. Interval of time, equal interval of time mean when one particle of the wave require 1 second to complete its one vibration, then other particles, for example, second and third particle take 1 second for complete its one vibration. So this describes the equal intervals of time. Wave motion required medium and source. Source is used for the production of waves. Now move toward the activity number 1. You can see in this figure a pencil is dipped in the tub of water. Now pencil is moved up and down vertically. The disturbance in the form of ripples produce water waves in the tub which move away from the source. Now a cork is present on the surface of the water on the other end of the pencil. So these waves are reached to the cork, and cork also start their motion up and down about their point. The net displacement on the cork is 0. So cork repeats its vibratory motion about its mean position. Now activity number 2. Activity number 1 describe how energy is transferred and how the source is required for the production of wave. Activity number 2 describe the direction of wave. In this figure you can see that take a rope and mark a point P on it. One end of the rope is tied with a hook that is a fixed point, and other end is firmly held on our hand. Now apply a force on a rope. Rope is start to waving in such a way that P point is still fixed, but wave is moved in forward direction. Wave is hit at the fixed point and rebounds and start their wave motion along a P point. P point is in still position. The motion of the P point will be perpendicular to the direction of motion of the wave. Now we will discuss the types of motion. There are 2 types of motion: mechanical wave, electromagnetic wave. Mechanical wave are those waves that require any medium for their propagation of wave. Example of the mechanical wave is water waves and sound wave. You can see that. Now move toward the electromagnetic wave. Electromagnetic wave are those waves that do not require any medium for their propagation. Example of the electromagnetic wave are radio waves, television waves, X-rays, light, heat. These are the example of electromagnetic wave. Basically, electromagnetic wave consists of electrical and magnetic field that are oscillating perpendicular to each other. You can see in the board, upper part of the wave is called crust and the lower part of the wave is called trough. Crust and trough are combined to make a wave. So crust and trough combine to make a wave. Thank you. Allah Hafiz. See you next time.